All right, so 4.3 is increasing. And decreasing. And the first derivative. Okay. So if you graph these, let's do an easy one. Let's do the first one. I'm sure you remember increasing and decreasing from college algebra, but let me go over it again. So problem 1. Identify the open intervals on which the function is increasing / decreasing. I'm just going to shorten it there. So they give us a function and they want us to know where is this happening. If you graph it, you can see right away what's going on. But I mean, that's not how we're going to do it, but I want you to see how that works. X squared minus 6x minus 16. Okay, you guys can see this, right?
Yes, sir.
Yes.
So the way I used to explain this in class was you go left to right, right? So this is the left side and right side, right? So if you picture a car coming from the left side to the right side, just picture a little car driving down. So if the lights are pointing downward, we're decreasing. And as soon as we turn around, this special point here, we start to increase. So we're decreasing from negative infinity all the way until 3. That's the x value. We always put it in x values whenever they ask for increasing or decreasing. And then we're increasing after this point, 3 till infinity. So it's super easy to see what's happening when you graph it, right? Increasing from negative infinity to 3, sorry, decreasing from negative infinity to 3, increasing from 3 to infinity. But how do we show that? Well, you got to find that special point, right? The which we talked about last time, the extrema. So take a derivative first, right? So step 1 is find g prime. Then so 2, set g prime to 0. So x is 3, which we already knew by the graph, right? We knew that something special happened at 3. That is our one of our extrema, our critical number. Okay. So let's go back to, let's see what the question asked, right? I said find the open intervals. So there's something called the let me see, double check something here before I start doing that. It didn't ask us to, but we're going to use the first derivative test. So number 3, use the first derivative test around the critical number to determine if it's a max / minimum, but also, and to find intervals. of increasing slash decreasing. So we're going to be doing this a little bit later, but I figure why not apply it to something easy so you can kind of get the idea, because we're going to do it a couple of times here, or a few times. So what I want you to do, the way it works, right? Create a little number line and put the critical number somewhere in the middle. Assuming you only have one. And then test on either side of that number. And by test, I mean plug in numbers to the left and to the right into the derivative. So choose whatever number you want, any number below and above the critical number, and plug it into the derivative. Okay, so pick whatever you want. I'm going to pick 0 as my test point, my little test point here. Plug in, I don't know, 4, I guess, test. Trying to plug in simple numbers. So g prime of 0 would be equal to 2 times 0 minus 6, which is negative. If your derivative is negative, that means your slopes are negative, right? Which means I'm decreasing in this section. So below 3, we are decreasing, which we already knew. Remember, I showed you the graph, right? With negative infinity to 3, we said we were in decreasing. So this proves it, all right? And analytically instead of graphically. Now, plug in 4, what do we get? 2 times 4 minus 6, that's 8 minus 6. This is positive. So since it is a positive number, we're increasing. So what you end up getting is this scenario, decreasing, and then right after 3, increasing, which means this right here, this shows us that x equal to 3 is a minimum. So let's slow down here a little bit. So first step, take the derivative, solve for x when you set it to 0 to find your critical number. Use the first derivative, which is called first derivative test, is what this is called, to determine if it's a maximum or a minimum. When we use the test points, that also tells us where we're decreasing and where we're increasing. So now we can answer the question, even though the question only asked for increasing and decreasing, we found out a bunch of information based off the first derivative. We are increasing from negative, no, actually, let's put decreasing first. Decreasing from negative infinity all the way until 3. Increasing 3 to infinity. Okay, so slow it down here. So any questions on any of these steps? Does it make sense or is it weird?
On number 3, when it says test, what's that word next to it? I can't make out the letters. Round?
First derivative test around the critical number.
Okay.
So I did more work than they asked on purpose, just so you have some good notes. Because all they asked for, increasing and decreasing, right? So this is what they wanted. They didn't ask for max or minimum, but eventually we're going to be doing that. So I might as well show you how it all comes out at the same time anyway.
Professor, I have a question. Can you hear me?
Yes.
Oh, okay. So the reason why x equals 3, that's the minimum, is that because on the graph it doesn't go below that?
Oh, it's because of what the derivatives told us, right? So when I picked a random point below 3, right?
Mhm.
I plugged it into the derivative. Let me hit focus. I plugged it into here and got a negative. If your derivative is negative, that means you're decreasing below the critical number. So
Yes.
I'm coming downward. Over here, you got a positive, and I plugged in a number above. So if I'm decreasing and then increasing, that means I have a minimum. That shape appears.
Okay.
Which, if we go look at our graph, we already knew that, right?
Mhm.
We knew it was a minimum.
So if they have a question like this and they show us the graph and they ask us the minimum, could we just look at it right there, or?
Well, the equations are going to get more and more difficult. So you need to
Oh,
show
okay.
your work right now. I mean, this is easy, right?
Mhm.
We can see it, but how
Yeah.
do you, if you prove it without a graph, this is how you're going to do it. Okay, so
Right. Oh,
take
okay.
your derivative, test below and above, and then determine what it is. For example, this next one is not a pretty parabola, right? It's really funky. So in the exams, I'm going to be asking you to use a first derivative test. I want to see this work. The graph can help. If you graph it, it can help you see what's happening, but you need to show your work. Okay. Here, let's do, so number 2 actually asks you for everything. So let's do it. Or sorry, number 6. So we're gonna do the same thing one more time. Okay, sorry about that. You guys cool on that page? Just trying to give you some time to. Okay, let's move on then. So given f of x equal to x squared minus 4x. First step is find the critical number. So this will be what we did last time. You guys remember? Critical numbers of, sorry, I wrote that all weird, f. So remember we said to find them, you have to take the derivative and then set it to 0. Right? So then 2x minus 4 equal to 0. 2x equals 4, x equals 2. Here is our critical number. You guys remember this from last time?
Yes.
Okay, so there it is. So now we're the new thing, Well, first, look at the question. Find the open intervals on which the function is increasing and decreasing. So this can be found by simply testing after the 2 and before the 2. So B and C can be done together at the same time. Okay. So what you do is you take the 2 and make sure that's your critical special number. You test before, you choose 0 because it's easy, and you choose something close to 2 because I'm hoping that's also easy. These are my test points. This is the critical. Okay, so plug in the 0, find out if it's positive or negative. The number doesn't matter. I just need to know, is it positive or negative? If it is negative, then that means we're decreasing below the critical number. So f prime of 0 would be 2 times 0 minus 4, which is negative 4. So I am negative below 2. The derivative is negative below 2. That means we're decreasing below 2. Does that make sense?
Yes, sir.
So plug in 3. So you get 6 minus 4, which is 2. That's positive, so I'm positive. So that means I'm increasing after 2. So this time I'm not going to look at the graph. I want us to just think about it using this information, because they're going to get uglier in a little bit. Okay, so that means I have this scenario going on, right? So this is a minimum because it's decreasing, increasing. If it was the other way, if this was plus and minus, then that would be a maximum because it'd be going up and then down, right? See what I mean? So,
Yes.
so where is the, where are we increasing? What would you say? What is the interval? Where are we decreasing?
I think increasing, would it be 2 to infinity?
Yes, increasing would be 2 to infinity. Now, the only thing we have to worry about is, do we put parentheses or brackets?
I think we would put a bracket on 2 and then a parentheses on the infinity.
Yeah, we can never put a bracket on infinity, so that's true. The only weird part is the 2, which I think is confusing. But if you notice, 2 is in the middle of increasing and decreasing, right? So it's almost like it's neither. So it changes at this point. So we can't include it. We have to put parentheses because of that. So decreasing would be the same. We can't include the 2. So we go all the way until 2, but stop at 2. Does that make sense?
Yes, sorry about that. Thank you.
No, it's good. I mean, sometimes that confuses me too. I'm like, wait, why don't I include the 2? But it's because it's like a weird special point.
And how do we know if we need to put a bracket? Like, what would be the difference?
For increasing and decreasing, I don't think there will be a scenario where you
Okay,
would put a
so-
bracket, but trying to think of one. It's just that it comes up whenever we do intervals. Brackets always come up.
Okay.
Just be careful for when it comes into increasing and decreasing. We can't include inflection points, which we'll talk about a little later. Let me show you the graph of this guy so it can make more sense. So see how this is the critical number 2, right? Right there. So from negative infinity up until 2, I'm decreasing, but at 2, things change because it's a point of change. I don't include it. And that's the only reason we don't put brackets. So right after 2, we're increasing. So the question becomes, is it both? You see what I mean? So to,
Yes.
so to eliminate that weirdness, we don't include it because we can't include it on both. So it's best to just not include it at all. But looking at that picture, did we have a maximum? Right. It goes up forever, doesn't it?
Would it be infinity?
There is no max because it doesn't stop.
Okay.
So when that happens, you just put does not exist. But there is a lowest point, right? See, there is no highest point. There is a lowest point. So that's going to be 2 comma -4. So if you didn't graph it, you would have to use you would have to plug in the 2 into the function, the original here, to get the -4 here. Is there any questions on this problem? Is the first derivative test making sense? Do you see how it works?
Yes.
Because that's
We
all they're
didn't
gonna.
see if there was a min or max for the last one we did, right?
We did not do that. No.
Oh.
You're right. Okay, let me find a harder question. Let's see here. Yeah, that one sucks. Let's do. No. X4 minus 4x plus. Oh, I see. Yeah, let's do this instead. Okay. Let's do problem 9. So consider the function 5 minus x times x plus 1 squared. Part A, you always got to start by finding the critical numbers. Sorry, I'm at my brother's house and his dog is missing my brother, I guess. Okay. Just ignore those sound effects. He's outside washing his car. She's just like watching him through the window, crying. It's kind of silly. All right, so here we go. So this is going to be a product rule, right? So here we go. Use our formula. So derivative of the first times the second plus the first times the derivative of.
Does that square on the outside make it a chain rule too, or is that like not chain rule?
It technically is, but the chain would make it just a number one, so it doesn't make a difference. Right?
Okay.
Due to the inside would be a one, right?
Mhm.
So yes, you are technically right. It just doesn't do anything. This one though would be, if it had a power, it would do something, right? Okay, so that becomes a -1. This will be bring down the 2, subtract 1, and then multiply by the dirt of the inside. Okay, so that'd be negative. I'm gonna go ahead and multiply this out. That would be x squared plus 2x plus 1 plus 5x plus 5 minus x. Shoot, 5x plus 5 minus x minus x. There we go. I'm gonna just move the 2 in front and worry about it later. I'm just multiplying stuff out. I'm not doing anything fancy. Distribute the 2, that'll give us this. Actually, I could combine these. Well, I'll have to combine it later. Negative x squared minus 2x squared, that is a negative 3x squared. Combine those. -2 is -4, minus 10, that is a positive 6. 10 minus 1. There we go. So there's the derivative. So remember, to find the criticals, the only reason I did the math was because I need to set it to 0. And the easiest way to solve this is to make it as simple as possible. So the derivative equal to 0 would, if we divide everything by -3, that'll give us this, right? So that'd be x, factor that guy will be -3 plus 1. So the critical numbers are 3 and -1. So we have 2 critical numbers. So this will be part A right here. Right. Any questions on the algebra or derivative? Is that okay? Actually, give me 1 moment, guys. All right. So, anyone have any questions so far? Sorry about that. Okay, so remember, we part B and C are kind of done at the same time a little bit. So the first derivative test, now that we have 2 critical numbers, we'll have to test in between both of them. So we got -1 over here, 3 over there. So I'm going to test 0, 4, I guess. I don't know, -2. Don't really matter what numbers you choose. I'm going to star my critical numbers and plug those into the derivative. So f prime of -2 is -3. -2 squared plus 6 times -2 plus 9. So that'll be 4 times that is -12. -12 plus 9, that's going to be negative. I don't really care what the number is. It's negative, right? The value is not important. Now, f prime of 0 is going to be -3 times 0 squared plus 6 times 0 plus 9. So that is 9 positive. Okay, now the last critical number that I chose, or sorry, test point, I mean 4. Negative 3 times 4 plus 6 times 4 plus 9. 16 times negative 3, is that 48, right? 24, 9. That is negative. So we are decreasing, then increasing all the way. And then over here we are decreasing. And then of course, we're still increasing this entire time, going upward. Wait. Decreasing, increasing. Yeah, I'm sorry, that's not a good picture. That's not right. I just don't have space. So the way we should think about it is this way. We're increasing and then suddenly decreasing. So this is a peak and a valley. There we go. Does that make more sense?
Yes.
So now we can answer the question, right? Where are we decreasing?
We had -1 and 4.
What's that? Sorry.
You asked where we're decreasing, right?
Yes.
So it'd be like -1 and
We are decreasing below -1, right? And after 3. You see what I mean? We're
Yeah.
going downward, going downward.
so it'd be like -infinity, -1, to -infinity.
Yeah, so infinity to -1. And then we got that other one, 3 to infinity. So we're decreasing in 2 locations. You have to combine them with a union. Now increasing looks like just one location, right? -1 to 3. So I'm only increasing in this little section. Does that make sense? Where is the minimum and maximum?
What would minimum be DNE?
Well, we have a minimum right here because if we go from decreasing to increasing, that it guarantees a minimum.
Oh
At
yeah, I'm
least-
sorry. Yeah, you're right.
And if
Thinking
we-
after 4, no, but it's because it just there's a minimum.
Yeah. So we have a -1 something. And then we have a maximum here, right? 3 to something. I don't know what those numbers are. The only way to find them is to plug them into the original function or to graph it. Ouch. Stubbed my toe. Let's see here. Let's graph it over here. So we were right? Minimum at -1, and that point turns out to be -1, 0. Just to save time, I'm not gonna plug it in. 3 and 32 is the maximum. So if you do this on the test, I'd say, well, just label this as your max and min, and then give me the points or the X values. Either way, it's sufficient. Any questions on this one? Okay, you guys, is it making sense so far? For this, what we're doing right now is called the first iterative test using critical numbers. So is it okay?
Yeah, I think it makes sense so far.
Okay. Because pretty much the entire homework is just find critical numbers, test around them, determine increasing, decreasing, maximum, minimum over and over again. Nothing changes. You guys want to do one more, or do you want to start doing some other homework problems? You guys okay?
Could we do one more?
Yeah, let me pick one here. Okay. Let's do 10, I guess. So given f of x equal to x to the 4th minus 4x plus 7. Find the critical numbers of f. So remember, that means find the derivative and set it to 0. So this will be a simple power rule, right? Set this to 0, which will require some factoring. Do you see how this is a difference of cubes? Let me pull up the formula because I don't remember what it looks like. There it is. Here's the difference of cubes right here. You have a cube minus a cube, it always turns into this. So we have x cubed and a 1, which can be written as a 1 cubed. So that will be the same. Should I go ahead and write it here? That's x minus 1 times x squared plus x plus 1. There we go. So it looks like this doesn't have a solution. Only this one does. So x is equal to 1. That's my critical number. I'm gonna put it over here. Save space. Guys okay so far? All right, so test points. So the derivative at 0 is equal to this, right? Negative. The derivative at 2 is 4 times 2 cubed minus 4, which is 8 times 4. 32 minus 4 is 28 positive. So I got this going on. It's the minimum, right? Minimum right there. Okay, so we can answer part B right away, right? Where are we increasing and decreasing?
Is it increasing at 1 to infinity?
Yep. Where are we decreasing?
-1.
Do we have a minimum?
It would be 1.
Yeah, X value is 1. Is there a max?
No, it would be
Yeah, doesn't look like it. There's no more critical values, so no. To find this actually show the work this time. If I want to find the Y value, I gotta plug it in. Oops, not to that one, the original. Because that's gonna be 0, obviously. So 4. 4. So that's how you find the point. You just plug in the critical number, the X value minimum, into the function. And that's what they got. Let's look at their answer. Right, so we took a derivative, found the critical number to be 1. We tested below and above 1 to find increasing and decreasing, which pretty much told us that this was a minimum, 1, 4. And there was no other critical number, so it does not exist. Max, there is no max. So that's pretty much it for section 4.3. You guys have any questions on the section? If not, we can do some homework problems. I don't know if a few of you emailed me saying you had some questions.
You got 4 from the derivative, right, for the minimum?
Though the 4, you to get the actual location, you got to plug it into the original,
Oh, okay, okay.
because the derivative only tells you about increasing and decreasing.
Right,
The
gotcha.
function tells you like locations on the graph.
If we don't continue to do any more notes, I just wanted to say I have a question whenever we're ready.
Yeah, what's like? It looks like no one's asking questions. So what do you want to do?
So I have a question on homework 3.7, question 6.
376. All right, let me go open it up. The arcsecant or cosecant?
Yes, the arcsecant cosecant 6x is mine.
Okay, okay. So we're gonna have to use that formula I gave you. Do you know what I'm talking about? This is 3.4. What'd you say it was? Sorry.
3.7.
3.7 problem 6. What numbers did you have?
It was arcsecant cosecant 6x.
6, okay. Arc cosecant of 6x is my f. So the derivative, well, we should write the formula. Formula says the derivative of arc cosecant x is equal to negative, it's always going to be a negative, it's built in, square root of, well, actually there's a little x in front. Formula is absolute value of the x times the square root of, let's see here, of that x, whatever that x is squared, minus 1. So our x is 6x. So the derivative will be negative 1 over absolute value of 6x times the square root of 6x squared minus 1, which will be negative 1 over actually, hold on, let me double check the formula before I go too far. Oops. Yeah, formula looks okay. Arcsecant. No, I'm in class though. Oh, hold on a second.
You're good, no problem.
Yeah, it looks like our formula is fine, but I did forget the chain rule. So derivative of 6x, right? Derivative of 6x is 6. So it should be times 6 technically. Let me make some space. Okay. That's my formula over here. So just put the 6 here, make it simple. So this 6 will cancel that 6. So I'm left with a negative 1 over absolute value of x square root of 36x squared minus 1. Should be this guy, this answer here.
Okay, yeah, because I was getting confused at first how to like use the formula. I was like, what do I do?
Yeah, so whatever's in here goes there and there. So 6x goes here, here. You just don't forget the chain like I did.
Oh, okay.
Because see how there's no 6 anymore? It's sort of like, okay, where'd the 6 go? Well,
Yeah, it canceled.
it has to cancel, yeah.
Right, okay, gotcha. Is it okay if I ask you another question? Sorry.
Yeah, of course.
Okay, so this one kind of relates to, so there's 3 questions, but they're all the same. It's in homework 3.8. It originally started on question 6. If you want me to share my screen, just let me know. If not, you could just pull it up.
3.8 question 6, you said?
Yes. I know
Yes.
6, 7, and 8 are similar in each other, but there was something that I couldn't figure out on one of the steps.
Okay. Yeah, so there's apply Newton's method to approximate the what's it called? The intersections, right?
Yeah, so it was asking applying the Newton's method to approximate the x values of the indicated points of the intersections. Continue the 2 iterations until 2 successive approximations differ by less than 0.001. Let me see what I had, because I got one of the first answers, but I couldn't figure out how to get the second.
Yeah, so when you found, which one did you find, the lower one or the higher one?
Let me see, I'm going back. So I found the larger value, but I don't know how to find the smaller value. And because of that same thing, I wasn't sure how to proceed with the rest of them because they're both kind of like the same thing.
Yeah, I mean, if this one was different because there was 2 locations. See how there's 2 points you have to approximate. So you found the one that's bigger, right?
Right.
So what was your starting point that you chose?
Geez, I don't even know how to read my own notes.
Because I think that it depends on that. Like check out the solution on this problem here. So if I choose a point that's close to the lower one, so something negative, right? Doesn't matter how negative. They pick -1 just because. So as I do the iterations, I want to get closer and closer to the one that's closest to this one, the point that I chose. So if I want the bigger one, then I got to pick a bigger number that's somewhat closer to that side. So over here, they just said, oh, well, let's choose +1, I guess. And as you keep doing it, you end up getting to here. So finding both depends, or finding one of them depends on where you started. So it depends what you started with.
Well, for the large answer that I got, I started at 1.5, but I don't know how to get the second one because I don't know. You choosing a number has always confused me. I mean, I know it may seem simple, but for me, I overcomplicate it just because.
Yeah, show me your picture real quick.
Okay.
Do you have it open? So you choose 1.5, right? For the first one.
Yeah,
The
that,
1.5 is pretty close to this one. So of course you ended up finding the bigger one. If you choose something closer to this one, you'll end up converging there. So choose negative 1.5 or choose -2. Don't matter. You're gonna end up landing here after a couple of iterations. So that's
Okay.
all you gotta do is do the same thing you did for this one. Just pick this number.
Okay, so like do like -2 or something.
Yeah, it doesn't matter what you choose. Just since you have the graph, choose something close to the answer.
Okay, gotcha. Yeah, because I remember I was remembering it right now and I did -1.5 and it was like wrong, but it makes sense when you say to the number closest to it, because then it should be, I guess, more approximate.
Yeah, 1.5 might take might take more iterations because it's further away. Also 1.5 is uglier to work with. I think -2 might be a little easier.
Is number 7 the same because on that one, because I know I have the X and a tangent. I don't know. I've always been really
Can you
like,
show me 7?
yeah.
7. Apply Newton's method. The intersection of the two graphs. Yeah, so yeah, it's the same. You're gonna subtract them. Except the only difference is you only have one value. So pick something close to here, it looks like. So pi over 2 is right there. The 3 pi over 2 is over here. So maybe pi would be a good one to start with.
Okay.
Because this is pi right here. This is pi. And it looks like we want to approximate over there.
Is there any way we could do the number 7 together though?
Yeah, let me see here.
Okay.
Number 7. Was yours x and tangent?
Yeah, it was f of x equals x and then g of x equals tan x.
Okay. And what section was it?
It's section 3.8.
Okay. So they give us f of x equal to x and g of x equal to 10. So h is going to be the difference. So x minus 10, right? Derivative will be 1 minus secant squared x. Now choose a number. I was thinking maybe pi or something a little bigger. If you look at it, this is pi, which is 3.14. 3 pi over 2. That's basically what? 6.2 divided by 3. So I think 3 or maybe 4 would be fine to choose in between here.
Okay.
So I'm gonna say, I don't know, x naught is 4. Okay. So we know the formula. And we said that to find the next one, we need the first one, right? minus the function at the first one over the derivative at the first one, or the previous if you prefer. So that will be, I chose 4. Okay, so that would be 4 minus tangent of 4 over 1 minus secant of 4. So I'm gonna have to use a calculator here because these are not pretty numbers, right?
I have a TI 36X Pro. How do I put secant in on my calculator?
Okay, let's use that one. Hold on, let's see. So what is secant as a reciprocal? Do you remember?
Um,
Because there's no secant button. I'm sure you noticed
right,
that.
yeah, no, it's,
So we gotta do. Okay, there's my fraction. 4 minus 10 for 1 minus. So here I have to do 1 over cosine, because 1 over cosine is secant. And then you gotta square it. Make sure I did that right, because it looks funky. All right, do that again. 4 minus. You got the same?
yeah.
Okay. Oops. One minus 1 over cosine, and squaring the bottom. Okay. Yeah, looks like we're right. So we get for x1 around to, I don't know, 4 decimal places, 6.1201. I guess that would be 2. Then I'll do it again. X2 will equal 6.1202 minus 6.1202 minus tangent of 6.1202 over 1 minus secant 6.1202. Okay. So I'm just going to use what I typed earlier and replace it with a bunch of, well, no, it's not going to be easy. (6.1202) minus 6.1202 minus tangent of 6.1202. Oops. One minus 1 over cosine of 6.1202 squared. Oh man. Lord, oh, there it is. Put decimal there. No, that can't be right. One minus secant squared is cosine squared. Oh shoot. Am I in degrees or radians? Radians. Okay, that's good. Hmm. Oh, I see why. Well, no, this,
I mean, I got a number. I'm not sure why it's giving you a syntax error.
what'd you get?
So instead of like doing it the way you did, I just put 6.1202 minus six. It's obviously going to be the fraction form. 6.1202 minus tan. Is it tan 4 still, or is it tan 6.1202?
It should be 10, 6.1.
Hold on, let me try something out. I'm not sure. Maybe I did it wrong.
Hmm.
Yeah, so I got 238.5247.
Yeah, I got the same. I was just concerned why it got so huge. So I'm wondering, the formula is fine. Derivative is on the bottom. This is on the top. For yeah, it's 238. Give me a moment. Let me double check something. This is called Okay. I want to make sure that we're on the right path before we continue, just in case. Yeah, looks like we're not wrong. But I think our initial decision is not good. That's funny. Cause yeah, it ends up exploding after the 238 ended up going to like thousands and then hundred
Okay.
thousands and then millions. So I'm like, okay, clearly I'm getting further and further away from the answer. So what went wrong here? Let's try. Okay, so it's all about that starting point. 3 pi over 2. Is 4.7, right? So I don't want to get too close. I don't want to be too far away. So I'm thinking using 4.5 might be better. I used 4 thinking it'd be fine, but clearly was not fine. I'm supposed to be getting closer and closer to 4.49. And that didn't happen. See, here's the solution. So I need to get here. I know it's somewhere before 4.7 because this is 4.7, right?
Right, gotcha.
So we should choose something closer. I think I chose 4, which is around here somewhere. I think that might be too far away because it gets kind of weird. When we did it, it went jump to 6.8 somewhere up here. Then
So
after that, it shoots up.
is it like about us choosing the right number? Because I know this is the same exact problem I was telling you about earlier. How I was like, does it choosing the numbers matter?
It matters, but it's I mean, usually, if you pick a weird number, doing it enough times will eventually get you.
Right.
But this one looks like it doesn't, which is interesting.
So what number did we want to choose instead?
Let's choose something closer. Let's do 4.5 because
Like 4.5?
4 was too far away.
Okay.
So when you start seeing the numbers getting too big, that's a sign that we should probably start over with a different number. But for the most part, they're like easier, but that one wasn't. Okay. So we'll choose 4.5 as our x naught, our starting point. H of 4.5 over H prime of 4.5. So that will be 4.5 minus 4.5 minus 10 of 4.5 over 1 minus secant squared of 4.5. So I'm going to use that one with the 4 and just plug in 0.5 wherever I can. Okay. There we go. So 4.5 is better. Looks like we got there on the first try, but we don't know that until we try again.
Right.
So 4.4936. We'll use, we'll round to 4, I guess. Oh, sorry, 3. So now x2 will be 4.494 minus 4.494 minus 10 of 4.494 over 1 minus secant squared of 4.494. All right, so plug that in. Okay. Yeah, it looks like it didn't change.
Yeah, I got the same thing.
Cool. So yeah, that's what they wanted right there. So it turns out if we're too far away, sometimes it can go wrong. If you notice it getting kind of exploding, like if the first and second and third are like completely different, they're not really close together at all, then you probably picked a weird starting point.
So basically, like to do these problems, like you do the big one by doing the positive, and then you'll get the smaller one by doing a negative.
If there depends really. I mean, if like on the other one we had things that were in the negative and positive, but
Right.
uh
Oh, okay. I see what I see what you're saying. I understand. Okay.
yeah, it's not guaranteed.
So whatever's within that range, you choose like what's how do I put this? I mean, yeah, I don't know how to word it since they're not both within a positive and negative range on this graph. What would I do for to find the smaller one?
Oh, this one only has one.
Oh, okay, my bad. I don't know why I was thinking of the last one, kind of like being the same.
Yeah, and the other one, since they give you a graph, you just pick numbers really close to it. So you have 2 different starting points.
Okay. And will I basically just use the same concept for number 8?
Yeah.
Okay.
What is
Gotcha.
Let me see. So here they're telling you what the initial guess is, x1. So they're asking you to try and calculate the other points. x2, x3, x4. if they exist.
Could you go ahead and say that for me one more time? So sorry.
So you start off at x1, right? They give you x1.
Yes.
Let me show you. So they give you a function as x1. So, but when you start, you're going to end up seeing that it's not going to work. You're going to get zeros in the denominator. The derivative will be 0 at 1. You see how it's a kind of like a minimum sort of.
Mhm.
So this is also called an inflection point. So when you take the derivative and plug in the 1, you're going to get a 0, which means in the formula, right, you have to divide by the derivative. You cannot divide by 0, so you cannot use 1. So it's not going to exist. You can't do it because of that reason.
Okay. So then we'll just proceed from 1 and then use the different numbers that follows, like 2, 3, 4.
Yeah, you cannot use something that makes the derivative 0 to
Oh, okay, gotcha. Right, right.
as a starting point.
Okay.
That makes sense.
Yeah, I did. At first, I was just really confused because with this chapter, I've been so busy trying to like just keep up that like I've had a really hard time like actually hard like concrete reviewing it. So it's just been really hard for me to grasp the information.
Gotcha. You guys have any other questions?
If no one else had any other questions, I have another question regarding 4.1. I don't know why, but for some reason it's asking us to find the absolute extrema of the function. And for some reason, I can only find like one of the answers, and then the other one, I don't understand why like my answer that I got wasn't right.
Which section you said?
It's 4.1, it's 10 and 11. They're basically the same thing, just different points.
Ten and 11.
Like on number 10, I got the, what was it? Let me see. Let me go back. Yeah, so for number 10, I got the maximum, but originally I thought the number that I got for the maximum was going to be the minimum. So now I'm just confused. So if I didn't get the minimum, then what is the minimum?
Okay. So we got 3x to the 2/3, right? Minus 2x. So the first thing you do is take a derivative. So that will be 2x to the negative 1/3 minus 2. Then you set it to 0. Now, you see how this is going to be on the bottom, right?
Right, yeah.
So whenever you have that, those are considered to be critical points.
Uh-huh.
So the only critical is going to be x equal to 0. Because it causes division by 0 on the derivative, but not the original. So we need to test this point, and that point to the original. So f of 0 is going to be 3 times 0 minus 2 times 0, which is 0. F of -1 is going to be 3 times -1 to the 2/3 minus 2 times -1, which is -3 plus 2, -1. Now plug in 1. You're going to get 3 times 1 minus 2 times 1. So these are the minimums and maximums, or possible minimums. So the smallest one is going to be, well, we have to plug them in, right? So we plugged in 0 to get 0. We plugged in -1. And did I make, let's see if that is that right? Oh, actually, I'm sorry. That's not right. This is the 3. My bad. This is actually 5. This is the biggest point. Yeah, there we go. So max is -1, 5. Minimum is 0, 0. So this one wasn't really important at all.
And so then I'm just trying to understand the minimum part, like why we declared it as, oh, okay. It's because f of 0 and then 0, 0. Okay, I see.
Right.
Yeah, at first I was like, well, how did we know that was it?
Yeah, it's just the smallest one. Whatever caused the smallest y value is the minimum.
Okay, cool. Thank you. Yeah, I was really confused about that. I was seeing like some demonstrations, but I just couldn't understand why that one was considered the minimum.
Gotcha. Does that make sense though? No?
Yeah, it does. Because I got like -1, 1 and 5, but I was just trying to like understand like why they put it as that. So
Okay. Okay. I think I need to go to my office hours. I'll scan this and upload it very soon. I'll see you guys Wednesday, okay? We'll stop
Sir,
here. Yes.
are you going to be in your office hours tonight?
Yeah, that's where I'm going to right now. So just log in there if you need some help or have a question.
Okay.
See you guys later.